Hello and welcome. This video is going to be a short one because I'm just going to show you some examples of log base 10 common log. I did mention in the previous video that log base 10 is commonly used by scientists, but let's look at some concrete examples of where we use them. Number one will be the decibel system, right? If you look at the numbers from 10 to 100 and the column next to it, the power ratio, I want you to see some patterns, okay? Say let's look at 30 decibels, that is 1000 in the power ratio. 1000 is 10 to the power 3. So 30 decibels corresponds to 10 to the power 3. Say if you move to 60 decibels, right, that's 1 million, which is also 10 to the power 6. So 60 decibels, 10 to the power 6. So if I move to 90 decibels, would you know what is the power ratio? Yeah, you guessed it, it's 10 to the power of 9. So you can see that as we move up in steps of 10 on the decibel system, that corresponds to a 10 times increase in the power ratio. So in a way, you can think of the decibel notation, right? The numbers on the decibel scale really is telling you what powers of 10 are we on. And that is log base 10, right? When you apply log base 10 onto something, you're asking what powers of 10 it is, right? That's exactly what a decibel system is doing, telling you what powers of 10 we are on. Okay, now let's move on to the Richter scale. Okay, the Richter scale again is something that we use in science to measure the intensity of an earthquake. So sometimes you might hear from the news that there's a 6.4 magnitude earthquake in Indonesia, there's a 8.9 magnitude in somewhere else in the world. You'd be like, 6 and 8, there's a difference of 2. I don't think it's that bad. Haha, it is actually in a log base 10 scale. Again, right? So be careful. A jump in one number in the Richter scale corresponds to 10 times increase in intensity. So maybe a jump from 6 to 8 is a 100 time increase in the strength of the earthquake. Yeah, like if your building was strong enough to withstand one earthquake, do you think it's strong enough to withstand an earthquake that's 100 times stronger? That really sets you thinking about what kind of challenges an engineer has when they are trying to make a building earthquake proof. You're talking about 10 times, 100 times, 1000 times stronger earthquakes. Okay, so that is also another application of log base 10. Now for my final example, we're going to look at chemistry. We're going to talk about the pH scale. When you want to measure the alkalinity or acidity of a solution, you use the pH scale. So let's talk about acidity, the concentration of hydrogen ions. Now, a change in just one pH number corresponds to a 10 times difference in the concentration of hydrogen ions. And that really drives the point home when your chemistry teacher in the lab tells you that, pH 0 is a strong acid, but pH 4 is a weak acid. You'd be like, that's only a difference of 4, right? But that is 10 to the power of 4, 10,000 times the difference in hydrogen ion concentration, 10,000 times the difference in corrosiveness in terms of rate of reaction. So please be careful when handling strong acids. And that's all I have for you today. Just 3 quick examples. There are more, but yeah, in science we typically use, common log base 10. Now in the next video, I'm going to talk about the origins of logarithms. What was the first ever base that was invented? What kind of conveniences did logarithms afforded to the people living in those times? And finally, how is it linked to standard form, which we use so much in science? And that might give you a guess on what is the first ever base that was invented. So I guess until then, I'll catch you on the flip-flop.